Hi guys, and welcome to section 5.6 on direct variation. So make sure you're following along with your packet and making notes, doing the mathematical computations with me. If you don't have your packet, you can make notes on a piece of paper. You don't need to necessarily have the packet to do the assignment. Additionally, you can pause the video, you can rewind the video, you can replay the video, so make sure you take advantage of these opportunities. All right, so direct variation. We're going to start off with a word problem. And I don't know how to say this word, but I'm going to try. A recipe for paella calls for 1 cup of rice to make 5 servings. In other words, a chef needs 1 cup of rice for every 5 servings. The data has been reflected here on our table, and the equation y equals 5x describes this relationship. In this relationship, the number of servings varies directly with the number of cups of rice. So the word here, key, is directly. There's a direct relationship between your x and your y. So if I'm looking at my data, I can see the values for my x are increasing by 1. It's increasing by 1, and it's increasing by 1 again. If I look at how my y's are increasing, to go from 5 to 10, I'm increasing by 5. So it's plus 5, it's increasing by 5, and it's increasing by 5 yet again. So the relationship is as x increases by 1, y increases by 5. And if you think about it, if I have 1 cup of rice, it makes 5 servings. So there's the relationship that we're speaking about. So this is what we're going to be reviewing in this section. The true definition of a direct variation is a special type of linear equation. Linear equation, so we're thinking about a line, or it could be a negative slope, so either way. That can be written in the form of y equals kx, where k is the non-zero constant called the constant of variation. So basically, it's a defined relationship. Defined. I left my stylus at work, so my writing will be even better. Relationship between x and y. A direct variation is consistent. It does not change. A consistent relationship between x and y in which y is always equal to a constant multiple of x. So as in our previous slide where we said when x is 1, y is going to be 5. There was a constant multiple. The multiple of 5 was how you got your y value. And in that situation, our k was directly related to the relationship between x and y, but we'll figure that out algebraically soon. There are some ways to identify direct variations. When you're looking at an equation, you must be able to write the equation in y equals kx. Y equals kx. So notice that we have the variable y that we've been dealing with, and we have the variable x that we're dealing with, and now we have this new variable k, and again, k is the constant of variation. Just want to make sure I have the exact same words. Constant of variation. Okay, so in our examples, tell whether the equation represents a direct variation, and if so, identify the constant of variation. Now again, to be a direct variation, I have to be able to put my equation in this form. So when I look here, I have my y equals kx. The value of k equals 3. So number 2 is definitely a direct variation, and the value of k equals 3. When I look at number 2 over here, if I solve for y, because if you notice in our equation y equals kx, y is isolated, so we're going to isolate it. I'm going to minus 3x from each side, minus 3x. I'm going to put my new equation up here. So y equals negative 3x plus 8. Is this going to be a direct variation, or is there a slight difference between our model and number 2? I see I have a y variable, and I also have 3x here, but I've got this constant that's being added. If you have a constant that's being added to your equation, it's not a direct variation. So in this situation, the answer is no, it is not a direct variation, because this plus 8, this constant being added, is what makes it not be a direct variation. Okay. Okay, so now we're going to try these two and determine if they're direct variations or not, and then also let us or decide what the k value would be. So what I would like you to do is please pause the video and try it, and then unpause the video and watch me do the work. Okay, so for the first one, I'm going to put it in y equals kx. So essentially, I'm getting my y variable alone right here. So I'm going to add 4x to both sides, and my equation becomes 3y equals 4x. Now I don't need to write the 0 anymore because I have something on that side of the equation. The 4x is going to hold its place over there. But I need to isolate my y, so I'm going to divide by 3. So y equals 4/3 x. I have no constant added to it, so this is in fact a direct variation. And the value of k equals 4/3. Okay, so moving on to the next one. Perhaps you can kind of foresee where it's going to go. I'm going to subtract 3x from both sides, and my equation becomes y equals negative 3x. Again, I don't need to write the 0 because the 0 is not really going to add any value to my equation. It's kind of holding that spot on the right side of the equation, which is now filled by a negative 3x. It is in the format of y equals kx, therefore it's a direct variation, and k equals negative 3. That's my constant of variation. All right. So now what happens if you solve y equals kx for the variable k? These are literal equations that we're solving. We've done this before. What I would do is I'm trying to solve for k. I look at x. X is attached through multiplication. Inverse operation is division. So my equation becomes k equals y over x. So in a direct variation, the ratio, comparing two things, is equal to the constant of variation, or k. Another way to identify a direct variation is to check whether yx is the same for each ordered pair except for where x equals 0. So essentially you're looking for that rate of change to be consistent for all of them. So the change in y is the change in x, and that would identify a direct variation. Let's see what that means. Okay, so we've already discovered how to tell whether the relationship is a direct variation through, oops, I didn't want that to happen, through writing an equation. So if I have y equals 3x, I know it's a direct variation, and I know that k, the constant of variation, is 3. Well, now the second method we'll explore is finding the direct variation through ordered pairs. So if I look at my table of values, I want to see what the change is for each of the pairs. So here I've got an increase of 2, here I have an increase of 2. If I look at my y values, I have an increase of 6 and an increase of 6. So in this situation, my y value looks like it's going to be 6. My x value is going to be 2. So the direct variation is 6 over 2, which we always reduce to 3 over 1. And now I've solved for k, because remember, we can switch the equation around. So k equals y over x. K in this situation equals 3 over 1. If I were to then put it into an equation, the equation could be written as y equals 3x. So now on the next slide, you guys are going to give it a try yourselves. So I'm going to put up the next slide, you're going to press pause, give it a try, and then come back to see the work done. Okay, so trying the first one, I'm going to see what my change is. It looks like I have a plus 2, and it looks like I have a plus 4. Interesting. Here it looks like I have a plus 2, and then it looks like I have a plus 4. So in order to see if I have a direct variation, I need to look at the x and the y's that I have. So the first one's 2 over 2, which can reduce down to 1 over 1. And if you look at the second relationship here, we have 4 over 4, which also reduces down to 1 over 1. So in this situation, it is a direct variation, and the value of k equals 1. Moving to the next one, let's look at our x's. We're increasing by 4, and we're going to increase by 2. And for my y values, I'm going to increase by 3, and then I'm going to increase by 3. So right off the bat, I really don't need to do any further analysis because I can see I have a nice increase here that's constant for my y values. But if I look at my x values, it's not consistent. So even if I create fractions out of them, I know it'd be 3 over 4 and 3 over 2. Those are not alike. So it's not a direct variation. Excuse me. And then finally, our last one. It looks like an increase of 2.5 and then another increase of 2.5, so that's beautiful so far. And if I look at my y values, I am decreasing. So I have a negative 10. It looks like I have another negative 10 from these two values. So I'm going to write it as negative 10 over 2.5. And I only need to write that once because I can see the exact same relationship is identified for both of the ordered pairs. But I can reduce that, and it's going to be a negative value. 10 divided by 2.5 is going to be 4 over 1, so my equation, or my k value, is going to equal negative 4. Wonderful. Alrighty, now we're talking about writing and solving direct variation equations. So let's read, this is the data we're going to be solving. The value of y varies directly, that's the important portion, with x. And y equals 3 and x equals 9. And they want us to find the value of y when x is 21. So method 1 is find the value of k and then write the equation. Well, we're going to take the version of the equation that's already solved for k because that's what I want to find out, and I already have values of y and x. So this is the better of the two versions to use. Then I'm going to substitute the values. K equals 3 over 9, and I can reduce that to k equals 1/3. So once I know what my constant of variation is, I can substitute it back into the original equation. And we have that. That's our formula. So y equals 1/3 k. Nope. Let's erase that because we know it doesn't equal 1/3 k. 1/3 is k. So y equals 1/3 x. Find the value of y when x is 21. So y equals 1/3 times 21. I'm going to cross cancel, and I get y equals 7. So for this direct variation here, if I'm solving for y when x is 21, the answer is y would be 7. We can also set up a proportion. So hopefully this is going to draw, you should remember how to do this, but we have y over x, which is the same thing as y over 9. So we have, all I'm doing is taking the values here. I define my proportion, which you guys make sure you define your proportions when you set them up. I plugged in the given values, and now I'm going to set up the proportion. X is 21, so that goes into the denominator. And y is unknown, so I'm going to cross multiply. 9y equals 63. Divide by 9, divide by 9, and we get y equals 7. What do you know? The same thing that we proved in the previous example. So those are two ways that you can do those as well. Okay, so in this situation I want you to try it. You can do one of two ways. You can set it up as a proportion, or you can create the equation. So that's your decision. So go ahead and pause it, and in a moment you will have the answers up on the screen. So make sure you pause it and try it first. So here are the answers to these two problems. You can go ahead and pause it if you want to look it over. The first one was solved using a proportion, and the second one was solved using an equation. Okay, and now what we're going to do is we're going to graph a direct variation. The first thing we have to do is write it. So if you're reading this over, a group of people are tubing down a river at an average speed of 2 miles per hour. Write a direct variation that gives the number of miles, so miles is going to be my x, and that the people will float in x hours. So hours is my x. So miles is my y, and hours is my x. So essentially you should see the direct variation kind of coming out. So I have k equals, my miles, I go 2 miles in 1 hour. There's my direct variation. My equation would be y equals 2k. Oh, I did it again. Y equals 2x. Okay, so now choosing the values of x and generating ordered pairs. There is my table. I have an X and a Y. We're talking about time. X is time in hours. We can't go back in time, so we only pick positive values. Okay, for this input, this function right here, we can do this in our head. So 2 times the value of 0, 2 times 0 is 0, so in this situation it would be 0. 2 times 1 is 2. 2 times 1 is, 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. So see, there's the increase that we expected to see. You can look at it quickly and know that it's a linear function as well. Because of the rate of change increasing on the left, increasing on the right, we have a constant rate. And it's a function because no x values are repeated. So the last thing would be to create your graph. Excuse me. And for my graph, I'm going to improvise. Okay. I could plot all my points showing the rate of change by 2. Okay. I would take my line and go up in the positive direction, not include any negative values. So that's how I would graph it. All right, now it's up to you guys. This is to see if you get it. So try this and we will go over the final answer in class. I hope you all have a great night and I will see you soon.